The volume of a sphere with radius r is given by 4/3 pi r cubed. A solid sphere of radius r that is made of a certain material weighs 40 pounds. The figure above shows half of a spherical shell made of the same material. What is the weight in pounds of the entire spherical shell if the outer radius is 5r and the inner radius is 2r? So what in the world is going on here? I must have stared at this question for half an hour, just picturing what it's even saying here. Everything about this question sucks. The way it's worded, I think is very confusing. What it's asking for, it's such a uncommon. They very rarely even talk about spheres here. And here they're talking about spheres, and not just the volume of spheres, but the weight of these spherical 3D objects. So this is something is definitely a WTF question. And I don't think their diagram is absolutely terrible, so I made a better diagram because. So what are they saying? We have a sphere within a sphere, so you can think of it. It's like a hard-boiled egg or something. So it has a shell around it, or it's like one of those Russian dolls or something. So the sphere itself is this guy here, the guy with the red center, and everything around that is the shell. And so here, this would be the same thing, but in a cross section. And so then what are they talking about here? When they're talking about our inner and our outer radius. So what does that even mean? So the inner radius is going to be this radius here. So that's just the radius of the sphere itself, and that is 2r, they say. And so then the radius all the way to the outside. So this is the radius of the shell to the center of the sphere. They are saying this is 5r. Now, what are they talking here about the weight of these spheres? So they're saying, so if we have, so here they're talking about this sphere here. This is another reason why this is very confusing. This has nothing to do with the sphere we have pictured here. They're saying there's some other sphere somewhere else, or it's a hypothetical sphere with a radius r, and that sphere would have a weight of 40 pounds. So we know 4/3 times pi r cubed, and that would be the volume. So it would be the volume times some constant. You can think of that, that constant is something like the density of our sphere. But I say let's just call it x is equal to 40 pounds. And actually, let me write this down here so we can have some more room. So 4/3 pi r cubed all times x is equal to 40. Then what is the weight in pounds of the entire spherical shell if the outer radius is 5r and the inner radius is 2r? So first, it's now here's another thing that's confusing. When they say entire spherical shell, what does that mean? It's to me, it sort of sounds like that means the shell plus the sphere inside the shell. But I think they're just saying what is the weight of the shell. An entire, I don't think, is necessary, and in fact makes this very confusing. So if we want the shell itself, so we got to find the volume of the whole thing of the shell plus the sphere, and then subtract out the middle sphere. And we got to find not just the volume, but we got to find the pounds of each of those. Okay, so we need, we can think of this as, so big sphere minus little sphere pounds. So big sphere pounds minus little sphere pounds. So what is, let's start with our little sphere because it's we'll build our way up to the outer sphere. So for our little sphere, what is our volume going to be? Our volume for that is going to be 4/3 pi times 2r, because that's our radius, cubed. And then this will also be times x to get our weight. So this will be 4/3 times pi times 8r cubed times x. And so what will that be equal to? So first, so we know 4/3 times pi r cubed times x is 40. So let's pull that out first. We got, so 4/3 pi r cubed x, and then we're left with just our 8 times 8. So this here is 40. So this whole thing is just going to be 40 times 8, which is 320 pounds. And what is the weight of our outer sphere going to be? Or really, it's both of these guys put together. So that will be 4/3 pi times 5r all cubed times x. And so this will be 4/3 pi 125 r cubed times x. So if we do the same thing, and we just rearrange this, so 4/3 pi r cubed x times 125. So remember, so this guy here is equal to 40. So we got to find what is 40 times 125. 125 times 4 is 500. Right, yeah. So 500. So 125 times 40 should be 5,000 pounds. So if we want the entire spherical shell, we got to find the weight of both the shell with the inner sphere, which is 5,000 pounds, then subtract out the inner sphere, which is 320 pounds, and that leaves us with 4,680 pounds. What a nightmare of a question. But they can ask it, I guess. Who knows what the intent is? I don't know if the intent is to actually give you a really hard question. Like, I think when I see a question like this, I almost think the intent is to suck you into it. You know, it's meant to waste your time, and the right answer is really to skip it or get out of it sooner, because they don't even really ask about spheres that much. So people aren't even going to really know. They're not going to really be prepared for this. So weird question, hard question, but still doable if you just take the time to do it. And who knows, if it comes up, maybe it'll be easy for you. All right, moving on.